this video, we are going to discuss how we are going to place the number of tubes in outside of the transformer. So in the previous problem, we have calculated number of tubes is equal to 158. Number of tubes NT is equal to 158. We have calculated. Now we have to place this 158 tubes in your transformer tank. So it should be available outside the transformer tank. Okay, so first I am drawing this diagram. This represents the transformer tank. This is the top view of the transformer tank. Top view of the transformer tank. So this side is width of the tank. This is length of the tank. I have represented everything in mm. The given dimensions are 0.65, 1.55, 1.85 meter. So this in meter. Here I have represented as mm. So width of the tank 1.55 meter. Here 1550 millimeter. Similarly 650 millimeter. Okay. So now the given, so we know that there are some constant values. The center between the two tubes is equal to 75 mm. 75 mm. Now roughly we can calculate. This is a trial and error method. So trial and error method only we can able to calculate. So the distance, the length of the width of this transformer tank is 1550 mm. So we can find out how much maximum tubes we can able to place here. We can able to calculate. So we know that distance between two tubes equal to 75 mm. Like that, how many 75 mm we can able to keep here, that we can calculate using this 1550 divided by 75 is equal to 20.6. So in one side I can able to place 20.6 tubes. Nothing but it may be 19 or 20 or 21. So on one side I can able to place 20. I can't able to place 158 at a time in one side. So I am splitting this. So one side I can able to place only either 19 tubes or 20 tubes or 21 tubes. So like that I can able to find out how much maximum tubes I can place in this lengthwise. So that I can calculate here. So the distance is 650 and the two centers distance between two centers of two tubes is 75 mm. So 650 by 75 is 8.6. Either I can place 7 or 8 or 9. So this is the minimum value. So if I am placing 20 plus 8 plus again 20 plus again 8, so this value is only 56, but the total number of tubes is equal to 158. So the remaining tubes I can go for the next row. Like that, based on the total number of tubes, I can increase the number of tubes, number of rows. You can see here in this diagram, you can able to see 3 rows. The first row consists of 20, second row consists of 19, and the third row consists of 20. This is not a constant procedure for all the design. It varies, depends upon the number of tubes. If the number of tubes are only 56, only one row is enough. Otherwise, I can go for more than one rows. It's a basic concept. Now, I told you that the distance is 1550 and the distance between two tubes equal to 75. Based on that, I can able to find out what is the maximum number of tubes in one side. So 1550 by 75 is equal to 20.6. So either I can select 19 or 20 or 21. So using some trial and error method, from this I can be able to select 1. So see here, trial and error method, case 1 is for 19 tubes, case 2 is for 20 tubes. Case 1, first I am considering 19 tubes. So 19 tubes nothing but I need the spacing between 19 tubes. The spacing between 19 tubes is 18. See here in this example here, how many tubes are here? 1, 2, 3, 4, 5. Here it consists of 5 tubes. For example, consider 1, 2, 3, 4, 5. 5 tubes. 5 tubes, how many spacings are here? 1, 2, 3, 4. So 4 spacings. Okay, like that, I am considering the first case 19 tubes. So 19 tubes means 18 spacing. So 18 spacing means the distance is 18 multiplied by 75 because one spacing is equal to 75. One spacing is equal to 75 mm. So 18 spacing nothing but 18 multiplied by 75. So 1350. If you are placing 19 tubes, it occupies the space 1350 mm. So what is the total width? 1550. So minus 135 is a remaining 200. So the 200 is a remaining space. You have to split this 200 in either sides. So here this side and this side. You have to give equal spacing between this side. So 200 by 2 is equal to 100. So 100 is a maximum value. It is not necessary to give 100. So it is not a proper thing. No need to select 19 tubes. Because still we can reduce this distance. This distance is high. The spacing is high. Still we can able to reduce this. So I am going to the second case. The second case is 20 tubes. So I am considering the 20 tubes. The spacing is 19 and the distance occupied by the 20 tubes. The length is 19 multiplied by 75 is equal to 1425. Okay. So the remaining is 1550 minus 1425 is 125 by 2. That is equal to 62.5. So 62.5 is a space between one tube and the wall. So we are giving spacing between between the wall and the first tube, center of the first tube. So this is 62.5. This is allowable value. So 100 is the maximum value, is not needed to give 100. So 62.5 is allowable value. So it should be equal on either sides. Here 62.5, here also 62.5. So this is acceptable value. So the 20 tubes is a correct value. Still we can check with 21 tubes. So if you are considering 21 tubes, the spacing is 20. So the distance occupied by 21 tubes. So spacing multiplied by distance, 1500. So remaining space is only 50. If you are splitting this for either sides, only 25. So 25 is very less. It is not allowable value. So only possible distances, only possible distance at the ends is equal to 62.5. So you can give 62 points. Here also you can give 62 points. So how many tubes you have to keep? You have to keep 20 tubes. If you are keeping 20 tubes in the first row, if you are keeping 20 tubes in the first row, on either sides you can able to give 62.5 spacing. So this is the arrangement in widthwise. Now you are keeping only 20 tubes, and so this side 20 tubes. So both these sides are equal. Here also you can give 20 tubes. So the first row consists of 20 on widthwise, and also the lengthwise you can able to keep the tubes that you have to calculate. Already I calculated that the distance here is 650 divided by 75, 8.6. So 75 nothing but it is a distance between two tubes. It's a distance between two tubes, 75 mm. And normally the diameter of the tube is 50 mm. Diameter of the tube is 50 mm. It's a constant value. So 8.6. So either you can select 7, 8 or 9. So here we are selecting 8. So spacing is 7. 7 multiplied by 75, 525. So 650 minus 525, it gives 125 by 2. So either side you can give 62.5, 62.5, similar to widthwise. So now the first row you have to give, but lengthwise 8. So now you have arranged one row, both widthwise and the lengthwise. See here, 20 plus 8 plus 20 plus 8. So 20 plus 8 plus 8 plus 20 gives 56. So the remaining 102. So remaining 102 tubes you have to keep. So it's not possible within one row. You have to go for second row as well as the third row. So if you are going for the second row, I am reducing randomly. I am reducing the values. So here I am keeping 19. I am not keeping against 20. 19 I am keeping here. Here it is 7, and here also 19, and then 7. 19 plus 7 plus 7 plus 19, again 52. So the remaining, again I am using random value for the third row. Against 20 plus 6 plus 6 plus 20 is 52. So totally is giving 160. Normally number of tubes are 158, but here I am selecting 160. So it is also allowable value. So the calculated value plus or minus 2 will be acceptable. You can't able to keep exact tubes like 158. It may go 2 more. So like this you have to place your cooling tubes. I hope you have understood everything. Given one tutorial problem, follow the same steps, complete the tutorial problem and submit it before tomorrow. Thank you.